Hey team, I've been playing around with Google AI Studio, which is a really powerful tool for building custom AI agents and chatbots. One of the really cool features in here is the ability to actually talk to the agent in real time, but also show your webcam or show your screen. One of the really cool applications I've been playing around with is getting it to actually tutor me through a calculus exam. But this can be done for any kind of your exams, tests, or really anything. So this video will be super sweet, show you how to set up Google AI Studio for free to tutor you in real time. So all you need to do is find Google AI Studio. You can do that by just simply searching, and you go in and you have to log into a Google account. You'll meet this kind of window here, and we want to go over to stream real time. Here we've got three different options. We can straight up just talk to it, we can show by using our webcam, or we can actually share the screen to show Gemini what we're currently doing. So for this one, we're going to go over to share screen. Also on the right hand side, there's a few different settings that you can change. The model is currently only for Gemini 2.0 Flash Experimental, that's sweet. And we want audio output when to speak back to us, and then you can change the voice in here, and these ones we don't need to worry about. So really, nothing to change. You've got a Google account, you can do this all for free. So click over to share screen, and we want to choose the one we're currently viewing, which is this one here, and we hit share. Awesome, can you see what I currently see?
Yes, I can see your screen. It looks like you're on the Google AI Studio page, specifically the Stream Real-Time section, which is currently connected to a server. Is there anything specific you would like to know about what I am seeing?
So that's crazy how fast that comes back, eh? So like there's very little delay between asking a question and it coming back and actually showing. And it can obviously see this here. So I've just muted that for now. I'm going to go over to find a level 2 calculus previous exam. Best way I found studying for them was just to do practice exams. So go to NCEA website, scroll down for the examination paper 2024, click on that and download, and we've already got it there, so download and come into here. When I use Canva, this is what I use to edit the PDFs, but you can use whatever you'd like, and we'll go here and drag and drop. Once it's in and all loaded, we can click that to open it, and we can zoom in a little bit. Sweet. Now that it's all set up, I want to go back to streaming real time, and I want to unmute myself, and we'll just go through the process and you'll see how easy it is. Alright, are you able to help me with this exam paper?
Yes, I see that you have an exam paper open titled Level 2 Mathematics and Statistics 2024. It appears to be from the New Zealand Qualifications Authority. How can I help you with this exam?
Yeah, so I just want a bit of help guiding through some of these questions. So I guess we'll start with question 1A.
Okay, I can help with that. Question 1. A asks you to find the gradient of the graph of the function f(x) equals x cubed, 6, x squared, plus 5, x plus 2, at the point where x equals 2. Do you have a specific part of the question you'd like help with? Or would you like me to guide you through the whole solution process?
I think I know how to do this one. I'll give it a go and see.
Sounds good. Feel free to let me know if you get stuck or want to check your work. I'm ready to help when you need me.
Just quickly going to mute that there so I can speak to you guys. I think the PDF editor hasn't correctly shown it, but this should be to the power of 3 and 2, and that one's sweet. So I'll go back. Alright, so looking at this, I think it would be, so we do 4x to the power of 3, which would be 12x2 minus 12 plus 5. What do I do with the 2 on the end?
Okay, I see what you've done so far. You've correctly applied the power rule to the x cubed and x squared terms. When taking the derivative, the constant terms disappear, as their derivative is 0. Therefore, in this case, the plus 2 at the end goes away. Does that make sense?
Right, so this is the correct function here.
You've got the correct derivative function there, but it is not completely simplified. Remember, when you are deriving a term like 6x squared, you need to multiply the coefficient by the power, and then reduce the power by 1. What would be the correct derivative of minus 6x squared?
See, made a mistake there myself, and I missed the x here, and it caught up on that. So I can quickly go back there, chuck that in, 12x plus 5, easy. Coaches you through it. One really cool thing about it is it doesn't just give you the answers, it actually gets you to think and kind of, coaches you through it in a way. Awesome, I fixed that there now. Now that I've got this x equals 2 to find the gradient, do I just substitute that into the function?
Yes, you are absolutely right. Now that you have the derivative, you would substitute x equals 2 into it. What do you get when you do that?
I'll give it a go. 2 squared is 4, times that, 48,
Okay, take your time.
minus 24, plus 5, and so then 24, so it'll be 29. Is 29 the answer?
Yes, 29 is the correct answer for the gradient of the function at x equals 2. You've successfully solved the first part of question 1. Do you want to move on to the next part, or do you need any more clarification?
No, that's awesome. Sweet, thank you very much. We'll actually look at a further one down. What about one of these excellence questions? Do you see this question here?
Yes, I can see question D, which asks you to calculate the dimensions of a cylinder with a volume of 500 milliliters that minimizes surface area. Would you like to start working on that one?
Yeah, I've got no idea how to do this one. Could you please just tell me how to do it?
Okay, I can certainly guide you through this one. This is an optimization problem, where we're trying to find the dimensions of a cylinder with a fixed volume that minimizes surface area. We'll need to use both formulas you're given. First, we'll isolate one of the variables in the volume equation and substitute into the surface area equation to get the surface area equation in terms of a single variable. Which variable would you like to start with?
Should we go for the radius?
Okay, let's start with the radius. The volume of a cylinder is given by V equals pi r squared h. Since we know the volume is 500 milliliters, we can rewrite this as 500 equals pi r squared h. Can you rearrange this to express h in terms of r?
Yep, so if we want to rearrange this, we'll take it all over, and the volume's 500, so it'd be 500 over pi h. And then to do the opposite of that, we square root both sides. So is that correct there?
Not quite. When isolating for h, you would divide by pi r squared and not pi h. So you have 500 equals pi r squared h, and you are looking to isolate h, you should be getting h equals 500 pi r squared. Does that make sense?
Right, so we're doing it for the height, not the radius. Sweet. I think it might have just cut out there. It does have a 10-minute limit, but we can just go back in and keep running. So we'll go back to stream real time. Alright, can you help me continue off and finish off this equation here?
Sure, I can help you with that. It looks like you're trying to solve for the dimensions of a cylinder with a volume of 500 milliliters, and you want to minimize its surface area. What have you tried so far?
I don't really know where to go from here. Could you tell me what to do next?
Okay, you have the volume equation, and you've solved for h. Now substitute the expression you found for h into the surface area formula. This will give you a surface area equation that only depends on ρ. Does that make sense?
Yep, I'll do that now. Plus 2
Great.
pi 500 over pi r squared. Is that correct?
Yes, that looks correct. You've substituted the expression for h into the surface area formula. Now you have an equation for the surface area that only depends on the radius, E-R-O-R-E. What is your next step?
You tell me.
Okay, to find the minimum surface area, you'll want to take the derivative of the surface area equation with respect to r, set it to 0, and then solve for r. This will give you the radius that minimizes the surface area. Would you like me to help you with that?
Yeah, how do I do that?
Okay, let's start with the surface area equation you have. SA equals 2 pi r squared plus 2 pi r 500 slash pr squared. First, simplify the second term by canceling out pi, then cancel out one air from the numerator and denominator. That simplifies the equation to SA equals 2 pi r squared plus 1000 slash r. Now take the derivative of the surface area with respect to r. Are you familiar with taking derivatives?
Yeah, so it would look like this if I simplified it. Pi r squared plus 1000 over r.
Yes, that's a correct simplification of the surface area formula. Now take the derivative of that expression with respect to r. What do you get?
Awesome, so if I do that, that comes there, so it's 4 pi r. And then how do I deal with this fraction?
Okay, you're on the right track with the derivative of 2 pi r squared, which is 4 pi r. Now remember that the term 1000 slash r can also be written as 1000 r. Using the power rule for derivatives, the derivative of 1000 r would be minus 1000 r squared, or minus 1000 slash r squared. So the full derivative of the surface area equation would be 4 pi r 1000 slash r squared. Does that make sense?
Sorry, what was that last term?
The derivative of 1000 slash r, which can be written as 1000 slash to the power of minus 1, is minus 1000 tosh to the power of minus 2, which is equal to minus 1000 divided by r squared. Does that clarify it for you?
Divided by r squared. Awesome. What next?
Now that you have the derivative of the surface area, set that equal to 0 and solve for r. This will give you the radius that minimizes the surface area. Would you like to work through that together?
Yeah, I don't have a calculator on me. Could you do that for me?
Sure. Let's set the derivative equal to 0. 4 pi r. 1000 slash r squared equals 0. First, add 1000 slash r squared to both sides of the equation. 4 pi r equals 1000 slash r squared. Then multiply both sides by r squared. 4 pi r cubed equals 1000. Next, divide by 4 pi. R cubed equals 1000, 4 pi. Finally, take the cube root of both sides to solve for r. That gets you approximately r equals 4.30. Now that you have r, can you calculate h?
Awesome. So now that I have r, I could just substitute it back into that volume of a cylinder equation, correct?
Yes, that's correct. Now that you have the radius, you can substitute it back into the volume equation to solve for h. Keep up the great work, you're almost there.
I also don't have a calculator. Could you just give me the answer? What is h?
Okay, you have 500 equals pi, 4.30, squared, h. First, calculate 4.30 squared, which is approximately 18.49. Then, multiply by pi, which is roughly 58.08. Now you have 500 equals 58.08h. So divide 500 by 58.08 to find h. That gives you an h value of approximately 8.61. So the dimensions of the cylinder that would satisfy the given conditions, while minimizing the surface area, are approximately a radius of 4.30 and a height of 8.61. Does this make sense?
Yeah, that's perfect. Thank you very much. Sweet.
You're welcome.
I'll stop that.
Is there
now.
anything else I can help you with today?
Now I'm muted myself. It should speak back to me. But yeah, that's just like an example of how powerful it is, and it actually coaches you through and helps you understand what is going on. It's like I can't remember how to do this from back in the day. If I spent some time I would, or I can just boot up the AI and it can explain it through to me. If you think that's pretty useful, check out some of my other content, leave a like and subscribe. Cheers.